Dividing Polynomials, Part 2. Using Synthetic Division, Example 2. So in the first video, we looked at long division of polynomials. And in this video, we're going to look at synthetic division. Synthetic is a shortcut, per se, for certain types of polynomials. So if you have a polynomial that is divided by something in the form of x minus k, k is just some constant, then you can use synthetic division to divide and simplify your expression. So let's get started. All right, so the first thing about synthetic division is we're looking at just the constant terms. So we're going to pull out the numbers from the polynomials to set it up. So the first thing you want to do is say x minus k. So if we have x minus k, we have this form, so we know we can use synthetic division. So x minus negative 3 would be plus 3. So the first thing we're going to do is change the sign of the binomial. And we're going to put that here because that's what we're dividing by. Then we're going to look at the coefficients for the other polynomial. And what you have to do is remember that if there's not a term, you do have to substitute a 0, just like with long division. So we start with cubic squared. We do not have a linear term, so we'll need a 0 for that. And then we have a constant. So we're going to go negative 1, 4, 0, 9. All right, now the first one is easy. Whatever the first number is here, it's going to drop straight down. So this comes down. And that just becomes the number here at the bottom. That's going to be your coefficient. That's supposed to be an arrow, but it doesn't really look like an arrow. So let me try that again. All right, then you're going to multiply by the 3. Okay, 3 times negative 1, and that goes here. So you're going to multiply here, and you place the number here. So 3 times negative 1 is negative 3. And then you add from here on out. So 4 minus 3 is 1. And then you do that process again. So 3 times 1, and it goes here. So 3 times 1 is 3. 0 plus 3 is 3. Then you multiply the 3 by the 3, and it goes here. 3 times 3 is 9. 9 plus 9 is 18. All right, so again, the first one drops straight down. Then you multiply, add, multiply, add, multiply, add. All right, once you do that, you have divided out that factor of x minus 3. So you're going to start with 1 less degree. So since we factored out x minus 3, we're going to start with an x squared. So we're going to start with negative 1 x squared. And then you just go in descending order. So the next term would be your linear term, plus 1x plus 3. And the last number is your remainder. So we have a remainder of 18 over x minus 3. Now, if you perform long division, you're going to get the same thing. So you can do long division if you prefer. This is just kind of a shortcut. It's a little bit confusing the first time you do it, but once you do it a few times, it's quick and easy, and it's really nice to be able to do polynomial division very quickly. All right, so to summarize, if you divide negative x cubed plus 4x squared plus 9 by x minus 3, the result is negative x squared plus x plus 3 with a remainder of 18. All right, let's look at example 3. Divide 3x cubed minus 2x squared plus 2x minus 5 by x plus 1. Again, we've got x minus k. So minus k would be negative 1. Again, you're going to change that sign of the binomial just because synthetic division is a shortcut, and the binomial has to be in the form of x minus k. So if it's in the form x minus k, that just means the opposite of whatever this is. All right, again, looking at the coefficients, we've got degree 3, 2, 1, 0, so we're not missing any terms this time. So we're going to bring down our numbers, 3, -2, 2, and -5. All right, always kind of leave a space here because you're going to be writing more numbers here. The first one drops down. And then I'm going to multiply -1 times 3 and place it under the -2. Then I'm going to add and get -5. Then I'm going to multiply again. -1 times -5 is +5. 2 plus 5 is 7. -1 times 7 is -7. And -5 plus -7 is -12. Again, I factored out x plus 1, so I'm going to start with 1 less degree. So since this is a cubic polynomial, this will be a quadratic polynomial. So I'm going to have 3x squared minus 5x plus 7, remainder -12 over x plus 1. And that's it. All right, a self-assessment. This is brand new information, so make sure that you understand what we're doing. Remember, this is x minus k, so go ahead and change the sign. Set this up. Make sure you've got each degree represented. If not, you have to add a 0. Here you're missing a quadratic term, so make sure you put a 0 for the x squared term. It is important where that 0 goes as well. And then try to answer the math practice reasoning question as well. And then we'll work these out together in just a moment. So just pause the video, take a couple minutes, try to do these on your own, see if you understand synthetic division. All right, hopefully you took a few minutes to see if you can do synthetic division. And if you got this answer, you did it correctly. So for A part, x squared minus x minus 9, remainder -12. And B part, 2x squared minus 6x plus 17, remainder -58. If you got those, congratulations. You're well on your way to being proficient at synthetic division. If you got a little bit wrong, it's okay. We will do some more practice. Make sure that you put the 0 in for your quadratic term and just kind of check over your work and ask questions if you need help. All right, math practice reasoning. Explain why you can simply bring down the leading coefficient of the dividend when using synthetic division. All right, so simply because the leading coefficient of x minus k is a 1, the leading coefficient of the polynomial divided by 1 is the leading coefficient. So if you multiply by 1, you get the same thing back. If you divide by 1, you get the same thing back. So basically, because to do synthetic division, it has to be in the form of x minus k, and we know that's got a leading coefficient of 1, so the first term will always just come down because of that fact. Example 4, evaluating a polynomial. Use synthetic division to evaluate 5x cubed minus x squared plus 13x plus 29 when x equals -4. So in this case, they're not giving us our factor of x minus k. They're just giving us k. So they want us to evaluate. All right, so we're going to take -4. We're going to do synthetic division. 5, -1, 13, and 29. Bring down the 5. Multiply. Add. Multiply. So -4 times -21 is +84. Add, I've got 7, 8 and 1 is 9. -4 times 97, -388. And you can do 29 minus 388 is -359. All right, so using the remainder theorem, if a polynomial f of x is divided by x minus k, then the remainder r equals f of k. So how we can write this is f of -4, because we substituted in -4. So f of -4 results in the remainder. Remember, the remainder is the last number that you have here. So negative 359. All right, let's look at one more. F of x equals 4x squared equals, 4x squared minus 10x minus 21 equals x equals 5. All right, so we're going to take 5. We're going to take our coefficients. We've got 4, negative 10, and negative 21. All right, we're going to bring down the 4. We're going to multiply. We're going to add. We're going to multiply. And we're going to add. All right, so we can conclude that I cannot add. This is not 31. 50 minus 20 is 30, and take one more away is 29. So I'm going to have 29 instead of 30. All right, check my math here. So, all right, so that is correct now. All right, so we've got f of 5. That was given. And the remainder is 29. So we can conclude that f of 5 equals 29 using synthetic division. All right, this is the last example on the remainder theorem. When p of x equals 9x to the 4th minus 45x cubed plus 37x squared plus x plus 2 is divided by x minus 2, a student can determine the remainder by evaluating p of 2. What is the value of p of 2? All right, so you can use synthetic division, but you also can just simply substitute 2 into this equation. Again, this is in the form of x minus k, but k in this case would be 2. So let's substitute 2 in and see what the remainder will be. This is one of the standards that you need to know, and it's something that typically you always see on the EOC. So this is easy and quick to do. Plug in 2 for x. So 2 raised to the 4th power, and then minus 45 times 2 to the 3rd power plus 37 times 2 squared, and then plus 2 for the x right here, and then plus 2 again. So if you type this in correctly, this will give you the remainder. So you can conclude that p of 2 equals negative 64. You can go ahead and do synthetic division if you want to check it, but it makes it nice to be able to just plug that in as well. As long as you type it in your calculator correctly, it will give you the correct remainder. All right, that's all for today's lesson. If you have any questions, please let me know.